And in this tutorial, we're going to be talking about the append method for our linked list. Now, what the append method does is take a newly created node and insert it to the back of the list. So right now we have our three properties. We have our header, our tail, and size. And these get all set when we call our default constructor for our linked list. So header gets set to null, tail gets set to null, and size equals 0. So there are two test cases. One case is if the list is empty, and the other case is when the list is not empty. So we're going to do case 1 first. So there are actually two ways to test to see whether a linked list is empty. One, we could check to see if header is null. If header is null, that means it's not pointing to anything. And that means that our list is empty. Or we could check to see if size is equal to 0. And that means that there are 0 nodes within our linked list and that it is empty. From here, what we can do is actually create our node. And I'm just going to call it node n for now. So now that we know that this is an empty list, so what's the first step? Once we create our node n, now we could have header point to the newly created node. So let's delete this. And we can also have tail point to the newly created node. So header always points to the first node within our linked list, and tail always points to the last node within our linked list. Since there's only one node within our linked list, header and tail are both going to point to our newly created node. Next, all that's left to do is actually increment the size. Alright, so now let's take a look at case 2. Alright, so now for case 2, we have an example here where the linked list is not empty. We have two nodes within our list. Our header is pointing to the first node, our tail is pointing to the second node, and our size is equal to 2. So now what I want to do is append a new node to the end of the list. So first step is, let's actually create our new node. We have our new node n, and now I want to append it to the back of this list. So what I could do from here is, since tail is already pointing to the last node within our list, I have access to this node. So now I could change what this node is pointing to. So instead of saying this node points to null, I could get rid of this and make it point to n. So now from here, all I have to do is update what the tail points to. Because this node is no longer our last node, n is our last node. And finally, all I need to do is increment the size. So now from here, let's actually code this. Alright, so now we have our append method. It's not returning anything, so it's void. And the parameter we take in is the data that we're going to pass into our one argument constructor of our node class. So the first step says create a new node. So the first thing we're going to do is just going to say node star n is going to be equal to new node, and we're going to pass in our data. So this is going to dynamically create our node for us. Now the second part, we have two cases. We have a case when the list is empty, and we have a case when the list is not empty. So let's do the first case first. The first case is pretty simple. We could test to see if the header is null, or we could test to see if the size is equal to 0 to see if the list is empty. So I'm just going to say if header is equal to null, then we're going to execute this block of code. So if the header is equal to null, well, the case is pretty simple. That means we need our header to point to n, and we need our tail to point to n. And n being the node that we want to append to our linked list. And since n is the only node within our linked list, both the header, which points to the first node, and the tail that points to the last node are both going to point to it. So now let's take a look at case 2, when the list is not empty. So I'm just going to say else, and I'm just going to bring this comment up here. And if the list is not empty, we could take advantage that tail is always pointing to the last node. So I could just say something like this. I could say tail arrow next, and we're going to point to n, which is going to be our new last node. Then I have to update the tail pointer to n, because n is our new last node. The last step is to increase the size, because we inserted a new node. So this is our append method for our linked list.